Good morning, everyone. It's Amir sir again here from Jesus and Mary Academy with the fourth lecture of chapter Solid State Solution. So today we are going to deal with a new topic, and the topic is solubility and the solubility of solid in liquid. So we are going to see the solution of solids in liquid. So what is solubility? The solubility of a solid in a liquid at any temperature is the maximum amount of solid that can be solute in grams, which can dissolve in 1000 gram of liquid. That will be the solvent to form the saturated solution at that particular temperature. So what is solubility? So solubility of a solid in a liquid is at any temperature of liquid at any temperature is the maximum amount of solid. So solid is in solute form in gram, which can dissolve in 100 gram of liquid solvent to form which type of solution? Saturated solution. Saturated solution means the solution in which no more solute can further be added. So such type of solution is called saturated solution. The moment you add one one more spoon of solute in the saturated solution, it gets accumulated at the bottom of the container. So such type of solution in which no more solute is further added to the solution, such type of solution is called saturated solution. It means there comes the equilibrium in between the amount of solute and solvent. Now what is the meaning of word dissolution? So the word dissolution means the process of adding solute continuously up till solvent keep on dissolving it is called dissolution. So what is resolution? The meaning of term dissolution means we can add more and more solute to the solution. So until we are adding the solute to the solution continuously into the solvent and keep on dissolving it, this process is called dissolution. Then we have next term, crystallization. What is crystallization? When solution gets saturated, means the rate of dissolution gets equals to rate of crystallization, then solid solute particle gets separated out of solution, which I have already said means the solution gets saturated. When the solution gets saturated, the small crystals of solute which is added to the liquid solution get precipitated at the bottom of the container. So that process is called crystallization. Again, when solution gets saturated, then solid solute particles get separated out of solution. Separated out of solution means they get accumulated at the bottom of the container of that solution. So at that when the equilibrium is reached, when the rate of dissolution means the more and more solute is added to the solution gets equals to rate of crystallization means no more further solute is added to the solution but it gets precipitated. So that is called crystallization. Now we have the factor affecting solubility of solid. So the first factor which affect the solubility of solid is one number, nature of solute and solvent. So what will be the nature of solute and solvent which are getting dissolved? And second one is the temperature. So let's start with the first one. What is the first one? So we have ionic or polar compound. So whom we call polar compound, which gets polarized and changes into ion like NaCl, dissolve in polar solvent like water. Water also get polarized into H plus and OH minus, and very little or insoluble in non-polar solvent like benzene and ether. As I have already said, polar dissolve polar, non-polar dissolve non-polar. As ionic compounds are polar, they dissolve in water which is also polar. But ionic compound like NaCl will not dissolve in non-polar solvent like benzene and ether. Similarly, non-polar or covalent or organic compounds like naphthalene, anthracene are soluble in non-polar solvent like benzene, ether, CCl4, and very little soluble in water. So polar dissolve polar, non-polar dissolve non-polar. So if there is non-polar compounds like naphthalene and anthracene where they will be soluble, so they will be soluble in non-polar solvents like benzene and ether, CCl4, etc. But they are very less or not soluble in water. So these were the first factor which affect the solubility of solid. Now we are moving to the next one. That is the example first example, common salt, that is a ionic compound, is more soluble in water than sugar. So what will be the reason why the salt is more soluble in water than sugar? So the reason will be because the salt is ionic compound and water is also polar. Common salt is also polar, but sugar is non-polar, that is a covalent compound. Therefore the common salt is more soluble in water than sugar. Second example is of iodine. So iodine is which type of compound? Covalent substance. So iodine is more soluble in alcohol or CCl4 than water. Little bit they are soluble, but almost they are not. So iodine, which is covalent substance, is more soluble in alcohol, which is also covalent substance, or CCl4, but not in water. Now we are going to see the reason why it is happening so. Why it is so? So the reason is due to strong electrostatic force of attraction between ions of crystals and polar solvent molecules, negative ion being attracted by positive poles of solvent molecules and positive ions by negative poles of solvent molecules. So here it says that due to strong electrostatic force of attraction between ions of crystal, for example Na plus and Cl minus. So Na plus will be attracted by the OH minus of water, while Cl minus will be attracted by the H plus of water. Oppositely charge attracts each other. Same things happens when we put the sodium chloride, common salt, in water. Let's see with the help of diagram. So the diagram itself says, so what is the shape of water? V shape, bond angle is 1 at 4.5 degree. So it gets polarized to delta minus to O, and H attends delta plus delta plus. So water is a polar covalent compound, water molecule, and we can represent it as also O, instead of O will show minus sign, and for H plus we show plus sign. What about the Na plus and Cl minus? So Na plus and Cl minus. So the plus charge will be attracted by the minus of water. Na plus will be attracted by the Cl minus. Same way the Cl minus will be attracted by the H plus, which is shown in the figure also. So Na plus will be attracted by the O minus of water, while Cl minus will be attracted by the H plus of water. The same thing is shown here. So dissolution of ionic compound in polar solvent. It is showing the process of dissolution of ionic compound which is solid in polar solvent, water, which is liquid. Thus water molecules pull ions crystal apart, and electrostatic force of attraction existing between ions of crystals are cut off. So what happens with the water molecule? Thus water molecules pulls ion crystals apart, and electrostatic force of attraction exists in ions are cut off. It is asking about the NaCl. Means when we put the NaCl in water, so what water molecules do? It breaks the electrostatic force of attraction between the H plus and OH minus ion, and between the ions of crystal, and cut off, means they get cut off, means they are attracted by the oppositely charged ions of water molecule. Thus ions move freely in solution are said to be hydrated. So therefore ions can move freely because the force which is acting in between the oppositely charged ions, that is Na plus and Cl minus, gets dissociated, and therefore the ions moves freely in the solution and are said to be hydrated, means they are getting hydrated. So that is the meaning of word hydration. Thus substance dissolves if hydration energy is greater than lattice energy. So what is hydration energy? That is the energy of the water molecules which causes the dissociation of ion which get dissolved in it, and the lattice energy is the energy which bind the molecules together. So if the lattice energy is weak, it means that ion will get hydrated, means the hydration energy is more. So therefore it is said the substance dissolve if hydration energy is more than lattice energy. If lattice energy will be more, then that substance will not dissolve in that water or that polar solvent. So keep in mind that lattice energy, if lattice energy gets weakened and hydration energy gets more, then that substance dissolve in water. Next, polar solvent like water. Water is called best polar solvent or the universal solvent. Why? Because it has highest dielectric constant. If someone have highest dielectric constant, it can dissolve most of the thing. Therefore, water is called universal solvent. And other examples like water polar solvent, other examples are water is one of them, best one. Another polar solvent example is liquid ammonia, liquid H2S and liquid SO2. Keep in mind these are gases also, but they can be liquefy also. Liquid ammonia, liquid H2S, liquid SO2, these all are the example of polar solvent. Now what will be the example of non-polar compound? Non-polar compound dissolve in non-polar compound. Now non-polar solvent, non-polar compounds, non-polar dissolve, non-polar substance. So if there is non-polar compound, where they will dissolve in non-polar substance. So solubility is due to the substrate and what type of interaction they have. So solubility depends on the solute solvents, substrate, and the type of interaction, which type of force is acting, it depends on that.